including difference equation, partial difference equation, fractional calculus, and their application in number theory, graph theory, and computer science. Dr. Brito has made outstanding scholarly contribution with over 165 research papers published in reputed national and international journals, along with the authorship of 9 academic books. He is the editor-in-chief of Journal of Computational Mathematica and also serves as the founder and president of Academia of Advanced Research in Mathematics. Dr. Brito has successfully guided 14 PhD scholars and over 55 MPhil students and is currently mentoring several others. He has been recognized with multiple Best Researcher Award from both his institution and Trivandrum University, and is recipient of the prestigious Don Bosco Faculty Grant. His contribution to academic leadership include membership in Academic Council and Board of Studies at Trivandrum University, as well as being the coordinator for various deep insight and thoughtful engagement. Thank you, sir. We welcome you.
Good afternoon.
So
thank you very much for a nice introduction. I take this opportunity to thank the management and the department for inviting me as a resource person for this international conference on contemporary applied mathematics and statistics. Okay. What is research? What is mathematics? Huh? Mathematics is nothing but play with the numbers and logic, right? What is the secret of success in research? I think that the secret of success in research is raising questions. The Isaac Newton raised a question, why the apple juice comes down? That's why he invented the force of attraction, right? So similarly, you should raise the question, and today's session, you should learn at least one concept. Then I will be happy. Otherwise, what is the use of presenting that my concept? You should learn at least one concept. Please try to understand at least one concept. If you can, okay. Next. What is the important identity? Can you say the important identity connecting the first natural number, the first whole number, the irrational number, the algebraic number, the complex number? Can you imagine? You know the very important simple identity connecting first natural number 1, the whole number 0, the rational number pi, the algebraic number e, and the complex number I. So e power I pi plus 1 equal to 0. This is the greatest identity connecting all the numbers. I would like to highlight the history of the system of numbers, development of system of numbers. Okay. So one is God number. God is one, and God created one. First person, first thing. Who is God? One who has no father is a God. Suppose if someone has father, he may become a God. So that is a one dimension. And God's number is one. So What is the definition of natural number? 1 is a natural number. And if x is a natural number, x plus 1 is also a natural number. That is the definition. So similarly, 1 is God's number. 1 plus 1, 2. When 2 is a natural number, automatically 2 plus 1 is a natural number. 3. Suppose 10 is a natural number, 10 plus 1 is a natural number. So you accept all the natural numbers. Okay. So the equation, how they develop the whole numbers. Who invented 0? Who invented 0? 0 was invented by Brahmagupta in the 6th century. The greatest contribution of Indian is nothing. Finding nothing is the greatest contribution of Indian mathematics. Okay. So this equation, x plus a equal to a has no solution in natural number. For example, suppose x plus 1 equal to 1. It has no solution in natural number. What is the first natural number? Put x equal to 1. 1 plus 1 not equal to 1. Is equal to 2. 2 plus 1. So natural number has no solution. That's why they invented the 0. Put x equal to 0. X equal to 0 is a solution of the equation x plus a equal to a. So they invented 0. That's why we have the whole number system 0, 1, 2, 3. Then mathematics is not satisfied with whole numbers, and therefore they raise a question: what is the solution of the equation x plus a equal to 0? Has no solution in whole number system. So, for example, x plus 1 equal to 0. It has no solution in whole number system. So they developed the integers. They invented integers. Put x equal to minus 1. Minus 1 is not a whole number. It's an integer. So that's why they developed the integers. Again, the equation ax equal to b. Ax equal to b has a is an integer. Ax equal to b has no solution in integers. So they developed the concept of rational numbers. For example, 2x equal to 3 has no solution in integer, no solution in whole number system, no solution in integers. That's why they developed the rational numbers. Again, this equation x square equal to 2 or x square equal to 2 has no solution in rational number system. That's why the irrational number occurs. Right? Again, the equation minus 1 is a integer. The equation x square equal to minus 1 has no solution in real number system. Therefore, they invented the complex number I, imaginary number, complex number I. So, I explained 1, Cots number, then the whole number 0, then the irrational number pi, then the complex number e. And what is e? What is identity? E power I pi plus 1 equal to 0. That is constant. Okay. So can you give what is the definition of pi? Do you know the definition of pi? In any circle, the perimeter divided by diameter is a constant, approximately constant. Whatever may be the size of the circle. If you take the small size circle, find the perimeter and divide the diameter. So using pi, we can estimate the radius of the earth. Radius of the earth using pi. Pi has so many applications. Suppose perimeter of earth. What is the perimeter of earth? Going from India to US, 21,000 kilometers. Return back from US to India, it takes 21,000 kilometers. So total perimeter of the earth is, what is perimeter of the earth? 42,000 kilometers approximately. So perimeter divided by diameter. What is diameter? 2 into radius. R is the radius of the earth. So perimeter divided by diameter is a constant. Even if it is small circle or even if it is large size circle. So that value is constant. So using the value of pi, for simplicity I type pi equal to 3.14. You say pi is a rational number, irrational number. What's the value of pi? Pi is a rational number or irrational number? Irrational number. What about 22 by 7? Is it an irrational or rational number? 22 by 7 is rational number, but pi is irrational number. That's a contradiction. Pi is irrational number, but 22 by 7 is a rational number, integer divided by integer. So there is a contradiction. Are you able to catch my point? Pi is irrational number, but pi equal to 22 by 7, but 22 by 7 is a rational number. How can a rational number equal to a rational number? So nobody finds the exact value of pi. Nobody finds exact value of pi. Pi is the approximate value of pi equal to 22 by 7. It's not the exact value. So that's why pi approximate value equal to, suppose you take pi equal to 3, then what is the radius by cross multiplication? 2 cancelled, then 21,000. So what is the radius of, without taking any scale or without taking any tools, we can evaluate the radius of the earth only because of the invention of pi. Who invented pi? Archimedes invented the pi. There are so many applications related to pi, like type checking. So E. Why I am explaining E? What is the first formula? E power I pi plus 1 equal to 0. I explained 1, I explained 0, then I explained pi, then I explained I. What is I? The x square plus x square equal to minus 1 has no solution. So that I exist. Then what's the value of E? Euler's constant E. E equal to limit n tends to infinity summation k equal to 1 to n 1 by k. Whether the series summation k equal to 1 to infinity 1 by k converges or diverges? Sigma 1 by n converges or diverges? Sigma 1 by n converges. Sigma 1 by n diverges. Sigma 1 by n diverges. Log n also diverges. Log infinity. I have proof, but time. So even though Euler invented that limits n tends to the summation k equal to 1 by n minus log n. You first find the summation k equal to 1 to n 1 by k minus log n. Then you take the limit. Like Fibonacci. So sigma 1 by n converges, sigma log n, sigma 1 by n diverges, log n diverges, even though this limit is constant. It's finite number. So this is finite number, this is infinite. So many proofs are there. But this is also not correct. This is not correct. You take the, so this limiting approximation property. Okay, this is one approximation property. And so what is e power x? E power x. You can do research from e power x only. What is e power x? 1 plus x by 1 factorial using Maclaurin series. So I have given you one proof. Oh, you raise one question. So cos x, this using Maclaurin series, you know about the cos x and log. It's a proof now, no need. My question is, can you express cos x in terms of exponential function? In terms of, can you express cos function in terms of simply exponential function? You think you can do research. You raise the question, what is e power x? What is e power x? E power x. You should raise the question. What is first term? X power 0. What is second term? X power 1 by 1 factorial. What is third term? X square by 2 factorial. Why should take the degree by increase by 1? Why not to take 1 plus x power 10 by 10 factorial. Why don't you take x power 20 by 20 factorial? Why don't you take x power 30 by 30 factorial? You raise the question. Then you can form a new function. So what is usual function? E power x. From the e power x, I develop another function that is called the, why should we take the shift value equal to 1? I write my shift value 5, 10, etc. Whatever I like it. So that's why, so this is the, I express cos x in terms of e power exponential function. What is e power ix power 0? Starting point ix power 0. The degree of the polynomial increases by not 1, increases by 2. That is the creativity. You should learn. You should raise a question. Why should I take every time 1 increase by 1 power, 1 power, 1 power? So that's why. So this is e power I 0, 2. Shift what here? What is shift value? 1 or 2? 2. So ix power 0, 1. Okay, ix power 0, 1. And ix square, ix power 4. What is the difference between exponential function and this exponential function? In the usual exponential function, degree increases by 1. Here degree increases by 2. That is the creativity. So that's why. But the sin x, so this is similarly I sin x. Sin x can be expressed by the generalized exponential function. You can check it. Okay. So usual exponential function increases point. Then so this is the proof of e power I pi plus 1 equal to 0. The famous identity e power I pi plus 1 equal to 0. This is simple. What is e power I pi? 1 plus I pi by 1 factorial. Here the power increases by every time increases by 1. So this automatically we get the proof of this e power I pi plus 1 equal to 0. So cos pi, you know cos pi plus I sin pi 0. So cos pi minus 1. You take this one. Okay. So this is my creativity. What is my creativity? Exponential function is modified or converted into another form. If you take s equal to 1, and k equal to 0, you will get the original exponential function. Am I right? So today you learned one equation, new exponential function, that is exponential function with the shift value. So e x power k comma s equal to, what is starting point? X power k by k factorial, starting point. No need to start 1. I take the first term as a x power k by k factorial. Okay, so and x power k plus, what is shift value? Yes. So k plus s factorial, etc. So I constructed one formula. What is the application? What is the use of this formula? That is important. Anybody can construct new definitions or new expression. But what is the importance? What is the application? That is important. Without getting any application, otherwise the terms cannot be useful. Okay. So today you learned one formula. Okay, I am happy about that. Okay. So this is here. What is the first term? Ix power 0 by 0 factorial. What is the shift value? 4. Okay. So you adding all these two, we get this to this. I share the PPT to all of you. You can get it from Professor Joshua. So that will be useful for you. So this sum of here shift value is s. First term, then I get the s term, then 2s term, 3s term. Remaining terms missing, right? If adding all the remaining terms, you will find usually exponential function. First x power 0 by 0 factorial, then x power 10 by 10 factorial. What about x power 1 by 1 factorial? What about x square by 2 factorial? They are missing. But it is occurs available in the e of x power 1 by 1 comma 10. So adding all the missing terms, you will get the usual exponential function. So can you express exponential function using 1. What is God's number? 1 is the God number. Without using any other numbers, you use only 1 and integration. Can you express exponential function? Can you express exponential function using 1 and integration? I can express the exponential function using the God's number 1 alone and my knowledge of integration. Okay? Okay, what is 0 times integration of 1 is? Sorry, this is 0 times integration of 1, then nothing times integration. 0 times integration of 1 equal to 1. Take it as obvious result. No integration, no difference, that is 1. What is 1 times integration of 1 from 0 to t? Change the variable t. What is t? What is t? Madam, what is t? 1 times integration of 1 from 0 to t. Right? What is t square by 2 factorial? 2 times integration of 1. There is a typing error. 2 times integration of 1 gives the t square by 2 factorial. What is t cube by 3 factorial? 3 times integration of 1. So 5 times integration of 1, x power 5 by 5 factorial. N times integration of 1. So using God's number and the knowledge of integration, I can express exponential function invented by Euler, 17th century. Okay. So this is sum of 3 times integration. So adding all these terms, you get that. What is this? Integration of 1. Just integration of 1. 1 times, 2 times, 3 times, etc. etc. Is the exponential function. So this you learn one more concept today. And here 1 times and 2 times, then 4 times, etc. Next one, 1 times, 3 times, 6 times, 9 times, etc. etc. So this is the way to develop the research activities. Okay. And this is some of all these theorems. Okay. So very simple expressions, very simple proof. You can easily understand all these things. And it's already I explained you. So what is EV of t power 1 comma s? Starting point t power 1 by 1 factorial, shift value s. Okay. So these are results. Adding all this that I already explained. This is the theorems, derivatives. You know 1 times differentiation, 2 times differentiation, 3 times differentiation. Time is 4. Do you know half times differentiation? 0.5 times differentiation. We do not 3 times integration. So you can easily, in the half times integration is available. So that's why just I explained this one. These are a simple concept and this one. Half times integration of exponential function equal to just increase the power. So this proves there. So m times integration. What is m times integration of our new function? You verify e of t per x plus k power m by. You put m equal to 1 by 2. This is m times integration. You put m equal to 1 by 2. You will get the half times integration. Using gamma function, you can calculate. You know 2 factorial. Do you know 1 by 2 factorial? Huh?
1 by 2 gamma of
Minus 1 by 2 factorial equal to gamma of 1 by 2. So gamma 1 by 2 equal to root pi. So we can calculate the factor for fraction numbers also. So, 0 times displacement velocity. Rate of change of displacement is velocity. So, 1 times differentiation of displacement gives the velocity. What about half times differentiation of displacement? You can raise the question, then you can do the research. 1 times differentiation of velocity gives the acceleration. Rate of change of velocity is acceleration. What about the 1.5 times differentiation? That is possible. Okay. So smooth landing. Chandrayaan landed moon. To get the smooth landing, we need the fractional derivatives. So this is the formula. In order to integrate nu times, you make an arrangement. You add a partner. Or partner, if you add a partner, definitely you can make a fractional integration. Who is the partner? I want to integrate f of t nu times. I want to integrate f of t how many times? Nu times. In order to integrate f of t nu times, I integrate 1 times by adding the partner. Who is the partner? 1 by nu minus 1 factor into t minus x whole power nu minus 1. If you add a partner with f of t and you integrate, you can get the fractional derivation. These are new results and so here who is the partner? I want to integrate x power nu minus 1. The 0 to infinity x power nu minus 1, finite infinita. Integral 0 to infinity x square, finite infinita. Integral 0 to infinity x square dx, finite infinita. Infinite, uncontrolled. To make it controlled, you add a partner, like partner. Okay. If you multiply by e power minus x, then what is Laplace transform? Integral. What is the secret of Laplace transform? If you don't multiply this partner, this integration will be uncontrolled. It's infinite. To control the integration to finite term, we need a female partner. That female partner is e power minus s. If you multiply male partner e power s, it again will become an infinite. So this is the secret of Laplace transform. If you replace e power minus s by 1 by nu minus 1 factorial into t minus x by nu minus 1, you get the fractional integration. Everything is based on the Laplace transform. Laplace is a very important person. He find one partner to control the integration. Who is that partner? E power I minus sx. If you multiply another partner, you will get the Fourier series or other Killing integration. So these are the secret of here. This is Laplace transforms. This is fractional. I shuffled the Laplace transform with my fractional partnership. You will get the new results. Okay, fractional Laplace transforms. Okay, so these are fractional derivatives, fractional velocity, fractional acceleration. I developed some concepts on fractional velocity, fractional acceleration, and so on. So this, anybody wants my slide? Most welcome. So due to time is over, huh? Thank you very much for your patience. So I developed these are some operators. These are my operators. My research scholars are doing all these operators. Just remove integration and put this operator. You will get one paper. Replace integration by delta inverse. You will get another paper. Replace D by this operator. You will get another paper. So many papers available in the net. You replace D by this operator and replace integration by D inverse, delta inverse. My students, my research scholars are published papers because of this secret. Replace all these operators. Possible to publish so many papers. So it transfer. Okay. Before Laplace sum, this is the signal. Any change is a signal. Okay. So this is one. And lastly, last one. Just for fun, huh? We read all these things. Okay, this one. Crickets in life. Batsman, students. Bowler, question paper setter. Stadium, exam hall. Scoreboard, marks it. Umpire, one who corrects. Third umpire, re-evaluator. Ball, question paper. Bats, answer paper. Bouncer, question out of the question. No ball, printing mistake. Batting track, easy question. Bowling track, tough question. Audience, parents. 4, passed in all subjects. 6, passed with the distinction. 3, failed by 1 mark. 1 counsel for mistaking totaling. Net practice, recent test. Clean board, failed in all subjects. Run out, failed due to shortage in time. Man of the match, class best. Man of the series, university best. Thank you. Thank you very much for your patience. If you have any doubt, please call me. Okay? Thank you. Any questions? No question means you are not able to understand my presentation. Okay. Thank you. Thank you very much for giving an opportunity. Once I thank the management and the department faculty members for inviting me for this conference. Thank you.
Now I request Dr. G. Meena Devi, Professor and Head, Department of Maths. Now I call upon Ms. A. Satyajyoti to deliver the vote of thanks.
On behalf of the organizing committee, I extend our heartfelt thanks to Dr. G. Brito Anthony Xavier for graciously sharing his technical session. We are truly honored to have you, sir. From your deep expertise and insightful guidance, your distinguished academic journey and prolific research contribution and inspiring leadership in the mathematical science have set a high benchmark for everyone here. Thank you once again, Dr. Brito, sir, for your valuable presence and for enriching this session with your wisdom and experience. Thank you, sir.
Now I request Dr. G. Meena Devi, Professor and Head, Department of Mathematics, to felicitate Dr. Brito Anthony Xavier with a memento. So please.
Now we are moving on to the valedictorian function.
This two-day international conference is a platform where equations meet innovation and theoretical elegance meets real-world application. We are immensely proud to share that this prestigious event is partially sponsored by the Tamil Nadu State Council for Science and Technology, TNSCST, under its partial assistance to conference scheme and Academia for Advanced Research in Mathematics.
Today we gather here not only to exchange ideas and discoveries, but to celebrate the growing importance of mathematics and statistics in shaping cutting-edge technology, solving global problems, and propelling research to new heights.
Over the course of these 2 days, we will witness a wide range of thought-provoking presentations, keynote speeches from esteemed experts, and dynamic exchanges that highlight the evolving role of mathematics and statistics in addressing real-world challenges.
In addition to being a platform for scholarly discussion, this conference served as a meaningful convergence of intellect, innovation, and interdisciplinary exploration. May the discussions and deliberations over these 2 days spark new ideas, challenge existing boundaries, and pave the way for future research and innovation. Now I call upon Dr. G. Meena Devi, Professor, Head of the Department of Mathematics, to deliver the report of the conference.
Good afternoon, everyone. So, as a coordinator of this conference, I take this privilege to tell you the statistics of the participation. We had a total registration of 268 registration, and this conference is in the hybrid mode, both online and offline, and it has been reached out in each and every part of India as well as the abroad, across the globe. And we had online presentation of 151. Online participation, we have 27 participations, 27 participants have participated through online. And in offline sessions, we have 54 presentations. And apart from that, we also had 36 participation from physically. And among them, there are 72 faculty members and 196 research scholars. And the number of institutions involved is more than 200. And among this, there are 17 government institutions that has just taken part in this conference. So overall, I hope everyone has just enjoyed this conference. And I think the 2 days international conference has served its purpose. So with this, just a brief report of the 2 days international conference. Thank you all. We also had a best paper on each and every technical sessions. So those results will be intimated through your mail and WhatsApp messages, because we're just consolidating. You will be getting it as soon as the consolidation is over. So now
I now kindly request Dr. S. Arumugam to give away the certificates to the participants. Ms. M. Shubha from Rajalakshmi Engineering College. Ms. Nadia R. from Rajalakshmi Engineering College. Ms. A. Ranjanam from Rajalakshmi Engineering College. Miss Anita M. from Rajalakshmi Engineering College. Mr. Neeraj J. from Rajalakshmi Engineering College. Miss C. Renuka from Rajalakshmi Engineering College. Miss Madhumita G. from Rajalakshmi Engineering College. Miss Jennifer Janani from Rajalakshmi Engineering College. Miss M. Janatul Firtosh from SRM University of Science and Technology. Miss Shweta T. from SRM University of Science and Technology. Miss Visalakshi Subramanian from Sri Venkateshwara College of Engineering. Miss A.H. Shola Nesam from Alagappa University for the best paper presentation. Now I call upon G. Gokul Vijay from SRM Institute of Science and Technology, Katangulathur for Best Paper Award. Mr. John Dayalan S. from SRM Institute of Science and Technology. Ms. Joanna Stephen from St. Joseph's College of Engineering. Ms. Logeshwari A. from Trice deemed to be University. Ms. Meghana R. from Price University. Ms. Jayalakshmi M.S. from SRM Institute of Science and Technology. Ms. S. Vijayalakshmi from SRM Institute of Science and Technology. Mr. Mohammed Arif from VIT Vellore. Mr. Gautam Vasan V. from VIT University. Ms. Sarala Devi from Sri Saram Engineering College. Ms. Monica S. from St. Joseph's Institute of Technology. Dr. V. Gayatri from Sri Venkateshwara College of Engineering. Dr. S. Deepa from Ishwari Engineering College. Ms. Merlin Thomas from Stella Maris College. Ms. K. Aishwarya from Loyola College. Ms. R. Jarina from Loyola College. Ms. V. Nandini from St. Joseph's College of Engineering. Ms. V. Manimori from Panimalan Engineering College. Ms. D. Sagaya Rani Jabba from Panimalan Engineering College. Ms. A. Shami Kamlana from Loyola College. Ms. T. Portugal from Sacred Heart College. Ms. T. Portugal from Sacred Heart College. Mr. Harish Vidyarthi from Rajalakshmi Engineering College for Best Paper Award. Mr. Barney Dharan from VIT Velu. Thank you, sir. Thank you, ma'am. I kindly request the participants, if you have any feedbacks, please come out to the stage.